We have already seen that the amount of available data is growing exponentially. All of this data needs to be stored, processed somewhere. And this is where the cloud comes into play. Every one of you are probably already in touch with the cloud through Google Cloud, iCloud, or Dropbox. Let's start with a question about your own computer. You're probably using it to edit your photos, run some data analytics, or compile some cool piece of code. So what would you prefer? Run all those operations on your own machine, or send them to a supercomputer who will run them in a fraction of the time, then send you back the results? Your answer will probably be, it depends. It depends on my upload-download speed, my machine processing power, the supercomputer processing power, and how much it will cost you. What I want to show you is that the economics of digital technology will make it better for you to process more and more information in the supercomputer, the cloud. To do that, let's go back to our 3 laws from Module 1. The exponential growth of processing power and communication speed made everything faster. Your computer, the supercomputer, and the connectivity between the two. Then 2 other things happened. First, investment in advanced processing power tends to flow more into the supercomputer versus your personal device. Second, communication speed doubled its growth rate when we entered the 21st century, whereas processing power has been growing roughly at the same rate. This means that it became relatively more efficient for you to waste a small amount of time transferring data to save a lot of processing time by using the supercomputer. This is the basis of what we call the shift to the cloud. In terms of revenue, the cloud services market is expected to grow at 19% per annum until 2020. That means it nearly doubles from 2016 to 2020. Therefore, in 2020, the cloud market is expected to be worth more than $150 billion. When we talk about the cloud, everyone has a vague idea of what it is, but what does it actually mean? What are cloud services actually comprised of? We are distinguishing 4 different layers of cloud services, depending on how deep the customer wants to be technically involved. Let's take an example to illustrate the 4 layers. We will follow Mia. Mia has just opened a web store selling karate equipment like kimonos, belts, gloves. Mia does not need to own the server storing all the product photos, descriptions, etc. She can outsource that type of infrastructure to a cloud service provider, such as Amazon Web Services. That is the first layer of cloud service, called Infrastructure as a Service, IaaS. Of course, Mia still needs to set up everything else on the web shop by herself. But at least the infrastructure, its security, and the backup solutions are taken care of. The second layer is called Platform as a Service, PaaS. As you can imagine, many of Mia customers would want to access her website on their mobile phone. So Mia decides to build an app. To do so, she can use Google App Engine as an example. To build the mobile backend that will host the code, manage the database, and even give her some analytics about app usage. The next layer is Software as a Service, SaaS. To manage a growing base of customers, Mia can buy a web-based customer relationship management software, like Salesforce, for example. Her customer data is managed centrally, synthesized into customer dashboards to help her decision-making. Last but not least, the fourth layer is called Business Process as a Service. For example, as Mia's business grows and she hires more and more employees, she might want to fully outsource the payroll management process, including payslip editing, the legal filings, the payment process, etc. Regardless of its size, a company can leverage cloud services in any of the four layers we just saw in Mia's story. Their choice will depend on business needs and the benefits of such a migration.